Okay, so we're going to use probability trees to show how to solve this 538 problem. I've used heads and tails, heads meaning make, tails meaning miss. You could coin flip would be the same thing. So after the two flips, if you only look at the third flip, the coach walks in and sees the third one as heads. In this version, there's only two possible worlds, and only one of them is consistent with the evidence. So we circled that one. You can see that it's 2/3 probability, so we're kind of done. 50% of the possible worlds, but only one that's consistent with the evidence, 2/3. Now, if you look at, if the coach walks in on the fourth flip, there are four possible worlds here. They're depicted here, and the ones that are consistent with the evidence of the last shot being a make or the last flip being heads are circled. Now, how likely are each of these four scenarios? Well, you can just follow in the tree. That's why the probability tree is useful. You can multiply this 2/3 by that 1/2, and you end up with a 1/3. 1/3 of all possible worlds are this world. This one's less likely because we started down here, so this is going to be 1/3 times a half, so 1/6. So now, among the scenarios that are consistent with the evidence, there's a 1/3 and a 1/6. How do we compare those? Well, really, we would convert these both to sixths and then compare only the numerators. So this one is twice as likely as this one. So you don't look at the absolute value, you look at the proportion, given that where we know these are the only two possibilities consistent with the evidence. So you get to a scenario where 2/3 likelihood that you're in this world and 1/3 likelihood you're in that world. Now you have to take that 2/3 for this one, multiply by the 3/4 that this implies, add that to the 1/3 probability you're in this world and the 1/2 resulting outcome that implies. When you sum all that up, you get to 2/3. So again, you end up in a place where it's 2/3. So already that's a little bit interesting. Let's expand now to the 8 possible worlds in which there have been 5 shots. The coach walked in on the 5th shot. I've circled again. Given that he's witnessed a miss, these are the 4 that are consistent with that observation. And once again, the same kind of math where we're just going to multiply along the tree. So this is going to be 2/3 times the 1/2. I mixed up the order, but it doesn't matter. 3/4 times 2/3 times 1/2 equals 1/4, which is we're gonna get that into 3/12 just so that they all can sum up cleanly. Here, 1/2 times 1/3 times 1/2 is 1/12. Same math here. 1/2 times 1/3 times 1/2 is 1/12. So then and then the same at the bottom. This time it's going to be 2/3. So it's 1/2 times 2/3 times 1/2. Now, if you go over here, we've got, again, taking just the numerator here, we can see that this is 3 of a 6 total of the numerator. So 3/6, 1/6, 1/6, 1/6 of the possible worlds that are consistent with the evidence, and then multiply that by what this implies. So heads, 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 tails implies 4/5. So 3/6 times 4/5 is 12/30. Here, the same math. This implies 3/5 times the 1/6 of the weighted odds. You get to it sums over here to 12, 3, 3, and 2 is 20/30, which is again 2/3. So we've proven here that in 3 shots, 4 shots, and 5 shot scenarios, it really all again boiled down to 2/3. In each case, the number of possible worlds becomes more numerous, but the likelihood of each of them goes down. And you can see that this top outcome continues to become less likely, but there are a greater number of outcomes lower in the tree that offset it, and it always sums to 2/3.